Our next presenter is Felix Poulin, who is with CBC Radio Canada, and he's also a major expert in the world of NMOS. So you'll be hearing from somebody who not only works on the theory, but actually lives this every day. So let's hear it for Felix for the growth of NMOS.
Thank you. Welcome. I see some faces familiar. Welcome to this presentation. Yesterday there was another presentation from a colleague, Jed Deem, who presented in general a tutorial about NMOS. So today I won't be going through all the specs. I will more talk about the roadmap in the future and NMOS and how the adoption is being carried on. So I'm also co-chairing, or what you say, user chairing the NMOS steering committee. So we share the steering of the whole roadmap of the NMOS in the AMWA between a vendor and a user, and that way we keep the balance and the connection with the users. So what is NMOS? If you don't know, or if we want to express it in a different way. NMOS stands for Network Media Open Specifications. So it's a set of specifications that enables the control plane of a media over IP system. So a media over IP system can work with ST2110 from SMT, but also AES67, IPMX, which is a Pro AV flavor of SMT2110, can work also with new types of transports like JPEG XS, and we're working also on other types of transports in the future. NMOS is providing a common control plane for all these different transport, or in a facility, can be on-prem, on the ground, or in the cloud. So when we talk about control plane, we talk about discovery, registration, we talk about provisioning and configuration, we talk about media connections, flow connections, and we talk about operational control. So today, NMOS is doing some of it. ISO 4, ISO 5 are well known for registration, discovery, and connection management. But NMOS is growing to cover all of those different aspects of control as we speak, and we'll go through that. NMOS is, you can see that as a common control plane that can work across different vendors, across different platforms. So there was a wide support for ISO 4, ISO 5. It's growing. It's also open, as in the open specification, as it's developed by a large community of vendors and users. The work is publicly accessible on GitHub very early in the work, so it's visible to the industry. And it's attached to an open source license as well. It's implemented. Every time we publish a new specification or a revision, has been tested, implemented by a number of vendors before even it's ratified. So that's a big difference from other standards process, where maybe we do a lot of paperwork before we publish. Now in this process, when it's time to publish, we really make sure it works and it's implementable in a good way. NMOS is testable. We have a test suite that comes with it, and as we develop new spec, we include tests in the test suite. So vendors and users can test the implementation properly, and it can be also included in the CI/CD pipeline of software. So when you do a new version, it can be tested automatically. NMOS is secured. It's by design working with RESTful APIs using HTTP, so therefore it's easy to use HTTPS with encryption, authorization. The adoption on this stage is limited as we speak. There's not a lot of vendors doing it. It's growing, but it's there in the design. So whenever it's needed, it's there, and we can adopt that. And finally, NMOS is easy. We work very hard to make very simple specification, good documentation, provide tutorials, test suites, open source. There's some existing open source reference implementations also that can be used to kickstart and get started. So recently, we published a number of additions to the well-known ISO 4, ISO 5, ISO 7, ISO 8 suite that exists already. So first of all, the idea that NMOS was from day one a format agnostic or transport agnostic control plane protocol. Now we have a recipe how to use it with JPEG XS RTP streams. So this includes ST2110-22 for compressed streams, but also IPMX that is using ST2110-22. Another publication, very recent, is the BCP 00202, asset distinguishing information. Anyone who experienced NMOS with a system that is relatively big will see it hard sometimes to find the resource and the registry. So far, the way to distinguish resources, nodes, devices, and the registry was to more or less rely on the labels that each vendor will decide how they describe their device, and there's different ways of doing that. So when you have a bigger system, it starts to be hard to find your device in that. So the BCP 0202 add some metadata information for each of the device, each of the nodes. So you can have the manufacturer, the product name, the instance identifier that can be the serial number of the device, and a function, what it's doing, especially for devices that are reprogrammable or virtual machines or things like that, that can have a different function in the time. We also have a number of things on this aspect. With the next one we'll look at is to provide writable user labels. So as a user, as an integrator, you can also push your own labels with your own internal standards in it and find your information as you need. What's cooking at the moment in the pipeline? So there's many different activities ongoing. The major train of work that has been happening since a couple of years is on the topic of the operational control. So really be able to control the live capabilities of a device, basically the knobs you have on the device. If you have a gain control, if you have a ProCamp, if you have anything, a joystick to control a PTZ camera, all these real-time control. There's IS-12 that provide a control protocol based on WebSockets. There's also the whole architecture of that control, how to structure the data with MS-0501, MS-0502. This has been tested in 4 or 5 implementations recently in a workshop, and therefore the spec itself, it's quite stable. Now we are waiting to add to the test suite. As we say, when we publish things, we want it to be testable as well. So we look for IBC for a real publication, a full publication of this spec. IS-11 stream compatibility management. If you know how the EDID system works in the HDMI world, it's that brought to NMOS. You have a display. We can do a number of resolution. It will publish a table of all the available resolution, and the sender to that display, the video card, for example, will adapt this resolution to the best resolution the display can take. Now we're using the same principle, but between a sender and receiver in NMOS. So there's a possible handshaking that can happen to, if the receiver supports JPEG XS or uncompressed or different formats or different resolution, then the sender can adapt to it using that information. And also the EDID itself is covered because that's an important use case for the IPMX looking at the Pro AV market. Couple of more transport type, H.264, X.265, that are being added also. and NMOS with SDI, NDI that will be included. So really, you see that NMOS is really becoming a common ground across all different formats, all different platforms, be it in the cloud, be it on the ground, be it hybrid. We also have discussions for more formats. One that is about to start is the MPEG transport stream. There's a good demand from some users about this one. We also talking about other transport, SRT, CDI, RIST, and there's no limitation in terms of what NMOS can do in that field. The last one I want to mention is very important to me is the configuration management. So it's the ability to configure the device parameters, and the low-hanging fruit for that, imagine you have devices that already offer a button in their user interface to download the configuration and to upload the configuration. We just want to provide this ability through the API so it can be automated. So you can that way retrieve the configuration file of the device, and then you can back it up, you can version it, you can go back to the previous version if it was working yesterday and you broke it this morning. So this will allow already a good way to configure a file and have a solid interface. Now in the future, what we want is to have the granularity to control all the parameters and really go into automation of provisioning with this. So I call this presentation the growth of NMOS, and I want to back this claim by some numbers. Last August, we did a JTNM tested event, so this big gathering of vendors who test their equipment against the different ST2110 and NMOS standards and specifications. And on the NMOS side of things, there was a huge growth from the previous event in 2020. Just before the pandemic, we had an event, and now we have growth of 118% in terms of equipment that were tested for NMOS, a growth of controller and registries, 75% more vendors, 35 vendors were participating, and 87% of all the devices doing ST2110 and JTNM are also doing NMOS. So it's clearly a sign of a wide adoption. And that's why on the EBU pyramid that you might be familiar with, there's a layer on operational control, and that layer becomes greener and greener just because of that growth. There's a solid adoption on the base parts of NMOS. Most 90% of the tests for ISO 4, ISO 5 were passed. Some of these tests are for very advanced features, so it shows also a good maturity of the implementations. More recently, I was talking about a workshop that took place in DB Broadcast in UK, and then 50 participants, 20 were remote because we can do this hybrid with the control plane hybrid testing. So it was an opportunity for prototyping those different specs that are cooking, doing interrupt testing, but moreover that people meet face to face to really have discussions to solve any problem that are remaining with the spec work. So the question of the title of the presentation is why do we need an open control plane and a common control plane? So the benefits for users and integrator is to have this common plane, this common denominator across all vendors, ground, cloud, hybrid. To avoid vendor lock-in, it's important when we invest that we can evolve that platform without changing everything in a few years down the line if a product doesn't exist anymore, for example, or if something major change in your roadmap, you still have your infrastructure you can repurpose and continue to evolve. And also the security aspects is very important on that, the control layer. This is a first place we want to get secure. For vendors and implementers is the fact that we don't want you don't necessarily want to reinvent the wheel. There's something existing, you want to build on that. Maybe put your energy to where there's a gap where something is very special, something is not covered. But other than that, try to reuse what's out there. The test suite also is a big benefit. So you adapt NMOS and you have the ability to test. And finally, the fact also that the specs, when they are published, they were tried before, they were tried in workshop, they were implemented by a number of vendors. So that's also less risk in terms of issues later on. So I would just say jump on the bandwagon if you're not already have done. We really work with a dynamic community, both vendor users working together, being very connected in terms of user needs. We really try to do specs that are useful, applicable to real case problems. We use a modern iterative process. So we have a very different ways of doing standardization, which is we time-bound our iterations, and we have a very continuous delivery of value in NMOS. So every few months you hear something new about NMOS. The incubator is a place where you can grow your ideas before we really start the spec work. So we can prototype, try things, think about ideas, what's the best way to do things. And when we know a little bit what we want to have at the end, this is where we really start the official specification work that is a bit more formal. We have an architecture review group, so that brings consistency across all the NMOS technologies, even if they are done by different parties. And we have those workshops that are really an opportunity for trying out implementation. So I would say if you're interested in this work, influencing the roadmap, influencing the work, learn about it, join the AMWA, bring your ideas, contribute, and especially use NMOS in your project and products. Thank you.